Hey guys, you should have already copied the notes, and I'm just going to walk you through a couple different practice problems just to make sure you understand how to use Desmos. This is the third time that I've recorded this video because the first video did not record my sound. So we're just going to do this as fast as possible. It's not super hard. I am going to start with this Desmos problem that's on the screen, the Delta Math problem that's on the screen, because that seems to be the easiest thing. This is what you're going to have to do. So we're going to add a table just like we did on Friday, and I'm going to add homework grades on the in the left-hand column in the X exactly how I see them. So I'm just going to put them all in, and then I'm going to put the test grades for Y in, again, exactly how I see them. I know that Delta Math has this button underneath the table that says copy values for calculator and open statistics calculator. You will not have access to that on the state test, so I don't want you to use that. I want us using Desmos. Highly recommend you do the split screen. It's super easy. So you do not need to see the scatter plot for any of these problems, but I'm going to press it anyway just to make sure that we remember how to do that. Here's what my scatter plot looks like, and then here's the regression, add regression button. We're going to press that. We are on linear regression, and we have our equation. Okay, it says write the linear regression equation, rounding all coefficients to the nearest tenth. I do have to type in y equals, this would be 0.9x minus 0.4. That's the equation. And so when I answer the second part, which is using this equation, find the projected test grade to the nearest integer for a student with a homework grade of 62. I'm using the equation I wrote, not the one with all the decimal places that Desmos gave me. Otherwise, Delta Math will mark you wrong. You do not have to write in the y equals. We do just want to put 0.9, and then we know the homework grade. It says the homework grade is 62. Homework grade is X, so we're plugging that 62 in for X. And then that's minus 0.4. I get an answer of 55.4, which would then round nearest integer as a whole number, so that would round to 55. Okay. Sometimes they will give you the test grade, and you will have to go backwards. And you can do that. Just grab yourself a whiteboard and do the math backwards. It's not terribly difficult. Okay, so that's how you would do your Delta Math. This is the only section you have on Delta Math. Okay, the other thing is for the worksheet that you should have already done, on the front of the guided practice, you had the average temperature, and we're putting this span in because we don't want to put 1957 to 1961. That doesn't make sense, and Desmos isn't going to know what to do with those numbers. So you're just putting in 1, 2, 3, 4, 5, and so on and so forth. On the back, you should have seen that we renumbered the years starting at 0 and defined our independent variable as years since 2010. And the reason is, if I put 2010 in here, let me show you what this is going to look like, what the equation comes out to be, and then I'll tell you what that equation would mean in the context of the problem, just to explain why we changed the numbers. Okay, so here's my regression equation, and I want you to look at this y-intercept. The Y values in this problem represent percent of total US music sales revenue from streaming. It doesn't make sense to say that in the year 0, the US had negative 11,000% music sales revenue from streaming. Like, that doesn't make any sense. And so putting the calendar years in for X makes your y-intercept represent year 0. But it doesn't make any sense to have data that goes all the way back to year 0. So that's why we renumber these. Ooh, okay, well, look, not that way apparently. There we go. So don't press enter. Also count correctly. There we go. So now if we change it, my y-intercept makes much more sense because it's suggesting that in year 0, according to the data, there would be almost 5%. And so that makes my independent variable the years since 2010, so that my y-intercept represents that first value in the table, which is 2010. All right, hopefully that's everything you need. Please email me if you have any questions.